Good morning. So let us solve as usual on Mondays the homework problems and then we continue. So the first question is actually very simple. So let A be this given set. Which one is false? So it means three of them should be true and one of them is false. So you have to choose the false one. But let me ask you, what is the cardinality of this set? 3. Yeah, so the elements, one of them is called A itself. The other one is a set consisting of one element itself, which is accidentally or coincidentally A itself. And the other one is also a set in which the only element is the set containing only B. That's the interpretation of that. So for example, if we come here, does A belong to, yes, A belongs to A. Is it true or false? This is claiming that element A belongs to the set A. This is true because of this one, yes? Is that right? Okay, what about the other one? This one is true or false? It's also true, yes, because this element, this expression, or whatever you call it, this set, is indeed an element within your set, so that is also true. But this one, is it true or false? This one is false because when you say that the set of containing only B belongs to A, you should see this among the elements of this set, but you just told me that the elements are this one and that one, and none of them is this one. So this is what we have to choose here. And what about this one? Is it true? Of course, because of that one, it is also true. But let us try to practice a little bit more. What do you think will happen if I change these, instead of belonging to, replace them with the subset relation? Okay, so for example, I would write A is a subset of A, the first option. The second option will be this one is a subset of A. The third one will be this is a subset of A. And the last one is a subset of A. So I changed the belonging to relation with a subset relation. I just want to practice because the problem is solved. But if you want, so is this true? Even this doesn't make sense because this symbol makes sense if you have a set on the left and a set on the right. This is not a set, so this is false. What about this one? Is it true or false?
False.
True or false?
It is false.
It is still false, yes? Because what does it mean? If this is going to be true, it means every element of the set inside the left-hand side should be also an element in the right-hand side. But the set on the left-hand side has only one element, and that element is curly brackets B. Is this one an element in the set A? No. So I was able to find some element within the set on the left-hand side, only this, which is not in your set. So this one is still false. Yes? Yeah, but if it was belonging to, it was true. Yes? So what about this one?
False.
It is still false because this claims whatever inside in the set on the left is also in the set on the right. But in the set on the left, you have only one element, which is just B. Can you find B among the elements of A? No, so that is also false. What about the last one?
True.
The last one is true, not because of this one, because of that one, yes? Because this claims that whatever element you have in the set on the left is also a member of the set on the right. And that is correct because the only element that you have in the set on the right is just little a. And little a, because of this a, is among the elements of A. So this will be true, this, as if you replaced it. But of course, that was not wanted in the problem. Let us go to the next problem, which is also very easy. What is the cardinality of this set? The set of all integers so that n to the third plus 2n equals to 3n squared. So it means that, in other words, what should I do? I need to find the elements of the set A and count them. Okay, because cardinality means the element of the sets, elements of the number of elements of the set. So I have to do the calculations. So if I go here, the equation given to us is what? N to the power of 3 plus 2n is equal to 3n squared. Okay, if I want to solve an equation, a polynomial equation of degree more than 2, the only method that you have learned so far is to factorize. So if I want to do that, I will move it to the other side. And as I told you before, the factorization is not something simple to do usually, but not about these kind of things. So you see that immediately it reveals itself that I can factor an n out. So the factorization is extremely simple in this case. I can factorize more, or if you want, you can say that this one, the product of two numbers is 0, either the first one is 0 or the second one is 0, and you can use PQ formula to solve that. But I would prefer to factorize it one more step, because these numbers are so simple that I can guess. I put one in here, one in here. I ask myself two numbers whose sum is -3 and the product is +2. So immediately it becomes clear that -1 and -2 are the numbers. So this is the full factorization of this expression. So then it means that the product of three numbers is equal to 0. This can happen only if at least one of them is 0, yes? Or n is equal to 1, or n is equal to 3. Are all these numbers acceptable? Can they get the visa to enter this set? Yes, because all of them are also integers. For example, if they have mentioned natural numbers and we are working in a school that 0 is not a natural number, you have to drop it. Yes?
Should be n equals to 2. Why is it?
Oh, yes, thank you. Okay, so the set A itself can be written as 0, 1, and 2. So the cardinality of this set, which is symbolized either by this notation or by that notation, of course, in your book, this is the notation they are using, like absolute value. The answer is 3. So this is the cardinality of this set. So then we have to choose this option. Yes? Any questions? Very simple. This one is also very simple. So I have given you two sets, A and B. We know that A is equal to B. We want to know x plus y. Yes, what is x plus y? Okay. Okay, so this is the question that we have. We want to make them equal. So you know that two sets are equal if they consists of exactly the same elements. Yes? So how can I make them equal? So for example, you see that 4 is already equal to this 4. So this means I have two more elements here, two more elements there. I have to make them equal. There is no way that I can make 2 equal to 5. So what I have to do, I have to make 2 equal to x minus y and x plus 2y equals to 5. Then it gives me a system and I can solve. Yes, that's very simple. So I would write that x plus 2y, you see 4 is already 4, so x plus 2y either should match with 5 or it should match with that one. But if I want to match this one with the last one, then the option that will be left for me is just matching 2 and 5, which cannot happen. So this will tell me that no, you have to match this one with 5, and you have to match 2 with the last one. Okay, so I can solve this system very simply. So I can just repeat the first one. I multiply this by minus sign, for example, and then add them up. So when I add them, this one and that one are gone, so this becomes 3y equals to 3, y equals to 1. If y is equal to 1, x becomes 3, yes? Instead of y, you put 1, move it to the other side, it becomes 3, so the question mark is x plus y, which is 4. So the answer for this problem is 4. But for example, if I want to make the problem a little bit more interesting, might be, can I say something like this? I'm just having some rough idea. For example, I write a equals to 1, Okay. And then let us say that set B, I'm just write A and B, and I say that A is equal to B. Can this happen? Yes. If A is equal to B, and then I want to find A and B, for example. This is one point. Do you remember I told you that in a set, the order of elements are not important, and we also said something else, yes? Repetition shouldn't be done in a set. I mean, if I repeat an element, it means that I can drop all those repeated elements. So whenever in mathematics books they talk about set, they presume there is no repetition there. So if you want to make this set which with cardinality 1, so in principle, if I say A and B are variables and I ask you what the cardinality is, you cannot answer because you don't know if A and B are the same or not. Okay? So if you know that A and B is so if they are going to be different, then the set B is of cardinality 2, the set A is of cardinality 1, and equality cannot happen. So equality can happen only if both of these elements are equal to 1. Then it means that the set A and the set B are also equal. So have this in back of your head. Sometimes they might ask this question. Any questions so far? Okay, so let us go to the next problem. The next problem is if two elements are added to the elements of a set A, then the number of its subsets should be increases by 48. The number of non-empty proper subsets of A is what? Okay, so you can think a little bit until I clean the board. Okay, so how can we solve the problem? I have a set A. I don't know how many elements are there in A, but I know that if I add 2 elements to this set, for example, let me say the cardinality of A is n. Let us say, okay? Okay, if I add 2 new elements to this set, so the cardinality will increase to what? N plus 2. According to the problem, the number of its subsets increases by 48. So what does it mean? It means that after I added 2 units to the elements of 2 new elements to A, the number of subsets of this set on the one hand should be 2 to the power of the cardinality. On the other hand, it is 48 more than the number of subsets in the previous case. What is the number of subsets in the previous case where the cardinality is still n? It is 2 to power n. So this number is 48 more than this number. So that is what, of course, this is easy, very easy to solve, but I wanted to understand how to translate that English sentence to mathematical symbols. Is that understandable for everyone? So this is the new number of subsets. This is the old number of subsets. According to this problem, the new number of subsets is 48 more than the old number of subsets. And then we have to solve this equation. This equation is, of course, an exponential equation because your unknown is on top. Usually, generally speaking, you need logarithms. But for these problems, that n, you know that n should be an integer. So there is a very simple way to solve. In principle, you don't need logarithms. So what you do, I move this to the other side. And this becomes 48. And then I factor 2 to the power of n out. So on the right-hand side, I just write 48. So can you tell me when I factor out, there is a minus sign left. What should I write here? What should I write there?
4 minus 1.
It should be 4 minus 1. So if you don't mind, let me write 2 to power 2. People can see better. Is that right? Yes, because if I multiply this back, then 2 to the power of n times 2 to power 2 becomes 2 to power n plus 2. So that part is correct. And then minus this multiplied by that gives me that. So everything is right. And 2 to power 2, 4 minus 1, 3. So this means that I will have 3 times 2 to the power of n is equal to 48. Then I divide everything by 3, so 2 to the n becomes 16, and everyone knows that n should be 4. But what the problem is asking about what? The number of non-empty proper subsets of A itself, is what? So what is that? So you know that in principle how many elements we have, how many subsets we have? 16. One of them is definitely the empty set, which the problem is excluding, and the other one is, of course, one of them is also itself, which is not called a proper subset. So how many things I have to take off? Now I have to take off 2. Either way, we don't need even to calculate n. Yes, because 2 to the power of n is the number of subsets, but I have to take 2 out of it. So it becomes 14. So the answer that you have to provide here is 14. That was easy. Okay, so let us go to the next question. Let A be this set and B be this set. How many sets X are there such that X is on the one hand a subset of the union, on the other hand the intersection is a subset of X? We want to see how many sets with this property I can have, and then type the number here. Okay, yeah, that problem is also simple. Yes, so what you need to do, let us determine what A intersection B is, determine what A union B is. Oops, this should be clever. Yes. So what should I write here? What is A intersection B? A intersection B means the elements in common, all the elements in common. So what are the elements in common? 2 and 3 and 4. Yes, this is the elements in common. This is, instead of this, it should be a subset of X. X itself should be a subset of the union. The union means the elements which are either in this one or in that one or in both. Yes, so it becomes what? 1, 2, 3, 4, and 5. Okay, and then you need to investigate how many sets are there. There's no formula for that, so might be we can learn how to count them later, but here, this is so simple, you can list all of them. So can you tell me, for example, what is the smallest possible set having this condition is this one itself? Yes, so one possibility for X is to have 2, 3, and 4. Because if this is the case, if X is 2, 3, and 4, this one becomes true, and 2, 3, and 4 is indeed a subset of that one, so that one is also true. So that is one scenario. Another scenario is I have to add some elements to this, yes? So let us, because I want to investigate all of them, so I have to be careful. So I have already 2, 3, and 4. I cannot go below this, because if I go below this, 2, 3, and 4 cannot be a subset. So this is guaranteed by looking at this condition. 2, 3, and 4 should be in your set all the time, okay? But you might add some other elements as well. So what can I add here? What? For example, 5. Is that correct? Yes, because this one is a subset of that one. This one itself is also a subset of that one. So this is another one. Is there any other one? Yes? 1? Yes? 1, 2. So these 2, 3, and 4 should be there. So if you don't mind, let me have this logic in the back of our head. 2, 3, and 4 should be there. But now you're adding 1 to it. Yes? So that is also acceptable. Is there any other one? Yes.
You add 1 and 5.
You add 1 and 5. So X becomes what? 2, 3, 4, and you add 1 and 5. Other possibilities? There is no other possibilities. Is there? Yes, Ahmed, you want to say something?
Can you have like the empty set?
No, empty set, this is not a subset of the empty set. Empty set is a subset of this one, I agree. But you need to give me an X so that these two conditions are simultaneously hold. Yes, do you understand that? If you say the empty set, then it becomes this relation. Okay, this part of it I agree, but this part of it is not acceptable. And then when you say this is a subset of this and this, it should be both of them to be true to make it, the whole thing to be true. Yes?
You have like 2, 3, 4, and then the empty set.
No, the empty set, okay, I understand what you mean. No, don't get confused. These are, so if you write this one, you mean, so you write 2, 3, 4, you write 2, 3, 4, and the empty set, yes? But this one is, this is true, but this one is not true. Because now, this relation is not true, because this is not the case that every element of this set is an element here. Why? Because an element of this set is the empty bag, which I call it the empty set, which is not here. So this is not a subset of that. Because inside this there is some symbol which is not here. Yes?
Doesn't the empty set belong to every set, right?
No. Who said that? Every set is a subset of every set, not the empty set. Sorry, the empty set is the subset of every set. This is correct. This is true. Regardless of what A is, even I don't need to know what A is. But this might be true, might be false, depending on what A is. Yes? For example, if A is just 1, this is false. But if A is 1 and this symbol, then this is true. So when we have laws in set theory, it means that they are always true regardless of what the set is. For example, this one is a law. We've proved that. Regardless of what a set A is, this is true. But this is not like this because it depends what A is. If A is this is false. If A is this is true. I don't understand which part of it is confusing.
No, but if you try to write it, you know that the empty set is a subset of A. Can you try to write it like in symbols, like the empty set, and then you write that it's inside of A. If you understand what I mean.
No, it is not inside of A, you know. So let me imagine like this: when you have a set of some A, if you want to imagine, you imagine that you have a bag. Inside the bag, you have another bag which contains an element which is A. So you cannot say that you cannot say A belongs to the bigger bag. A belongs to the smaller bag. It's not very hard to understand that, okay? But the whole bag and what is inside is something inside of the bigger bag. So this whole combination is an element of the bigger set. Yes. But now what you are saying is that what should I do if I remove it with empty set?
Exactly.
So if I put this empty set, the same story again happens. But this time might be a little bit more complicated. If you see this as the empty bag, so what is happening here? You have a bag, the bigger one. Inside that bag, yes, you have this bag, which contains an empty bag. Yes? And again, the same story, the empty bag. So this one contains this object as a whole, not this one inside it. You understand what I mean? Yeah, so I don't understand the question then. No, think about it. It's not complicated, is it? No, just remember that what we proved is this one. And I just gave you the example. Do you feel that if I write this set like this, and if I write this set like this, for one of them, this is true, for one of them, it is not true?
Yes, yes, that I understand.
So if you understand that one, I think the problem is solved. So what he is mentioning, because you followed his argument, are you doubting that this is not a subset of that one? If you doubt about it because you are confused between belonging to and subset again. So this is wrong. This one is wrong. Because when you say this is a subset of this, it doesn't mean the elements are subset of this. It means the elements belong to this.
Yes, exactly.
Okay, this belongs to this, yes. This belongs to this, yes. This belongs to this, yes. But do you see this does not belong to your set? So this means there is an element in this set which is not an element from this set. So this means subset relation is violated.
Exactly.
Yes. So, okay, so understandable? Yes?
If you write like curly brackets,
Let me write because I cannot remember. So curly brackets.
inside of it, inside.
When you say empty set, it means this one or this one. These two are the same. Okay, so it doesn't matter. So which one do you want to put there? This one? Okay, so, okay then?
Then you can see that that's not a subset of the.
No, this is not finished yet. Should I close the curly bracket? Yes? Okay, so now this set, what is the cardinality of this set? 1. What is inside it? The empty set. The empty bag. Something like an empty bag is inside this set. Okay, now what is the question?
So is this a subset of 1, 2, 3, 4, 5 or no?
No. If you write this, this is wrong. This is correct. Yes, because when you say this, it means that, first of all, when you have this symbol, the left-hand side should be a set, which is of course true, it is a set. The right-hand side should also be a set, which is also true. So far, so good. And then this becomes true if every element of this set be an element of that set. But let me ask you, what is the only element of this set? Is this symbol? Yes? Is this symbol among the elements of that set? No, so that is false. But this one is true. Because I told you that we proved that. Because if this is not to be true, if this is not going to be true, it means that you could find something here which is not there, but it is not possible. Empty set does not contain anything. So that is proof somehow by contradiction or contrapositive. So this we prove that the empty set, this symbol or this symbol, it doesn't matter, it is always a subset of any set. Even I don't have access to the elements of the set on the right. Yes? Happy or not? Yes, okay. So now we go to the next problem, and probably this is the last one. Okay, so let k and n be natural numbers such that k is less than n. How many sets x are there such that this happens? So I have a set containing elements from 1 up to k in order. Union x gives me the set 1, 2, 3 up to n, but be careful, k is less than n. I want to see how many options are available for me for this set so that this equality becomes a true equality. And the options are a little bit more confusing. I mean, this is a good problem. Okay, so let us try to give you a little bit of time to think if you haven't already, and then we discuss it together here. Okay, any clues? How should we solve the problem? How many sets like X I can find so that when I union this, It gives me, for example, one way, if you are confused about letters, just replace them with numbers to get an idea, and then you can generalize the idea. Yes, for example, I have to choose two numbers. So let us say that k is, for example, 2. Don't make it so big. And let us say that n is, for example, 4. For example, I am respecting this condition. And this equation reads how? K is 2, so it becomes 1 and 2 only. 1 up to k is 2, so it's only 1 and 2, union x, and then I want to make it 1, 2, 3, up to n, 4. Yes, I want to make it. So how you think about the problem? Let us solve this problem, because if you cannot solve this one, there's no hope that you can solve the general one. So this is simple. How many choices, similar to the problem that we did before, how many choices I have for x? So you know the union, 1 over 2 will be in this union. What are the choices? For example, can I have only x to be, can I choose this one only to be 3? Of course not, because then it becomes 1 and 2 union with this one, which will give me 1 and 2 and 3. But I want to have 1, 2, and 3, and 4. So this is not working. So the one thing that immediately comes to mind is to write what? This is one option. Because if I choose x to be this one, the union of these two becomes exactly this one. But is this the only option? No. Then this is essential. In x, this is definitely the case that I have to have 3 and 4. Because if I don't have 3 and 4 here, there will be no way for me to have 3 and 4 in the union. So this is the minimal choice that I have. Yes? At least 3 and 4 should be here. This is itself one option. What is the other option? For example, what can I do? Yes?
3 and 4.
3 and 4.
You can add 5.
And for what?
You can add 5, for example.
No. 5 will not work.
Why is that?
Because if you union them, 5 will also be in the union. If you say this one, and I ask you union this with this, you will say 1, 2, 3, 4, and 5.
Oh,
But this is not equal to 1, 2, and 3, and 4. So you cannot go beyond these numbers. So everything you have the freedom, you have to play around with the numbers up to 4.
okay, so you can add,
So for example, you can add 1. Yes? Because now if I union this with that one, 1 will not repeat itself 2 times, so it becomes 1, 2, 3, 4, and 1, 2, and 3, and 4 again. Yeah, so that's another option. But is this the only one? You can see. So I want you to discover the idea so that you can answer the question, the general question. So let us try to understand everything. One of them is probably what? The first one that probably comes to mind is this one. But let us try to understand, because if you just randomly guess, it is not going to work. We have to be organized in understanding what is going on. So for example, we learned that 3 and 4 has to be in x. There is no escape from that. But this time you added 1 to it. But is 1 the only one I can add to my list? Yes, you can add 2, but be organized, okay? So 2. So here, how many elements I added? Nothing. Here, how many elements I am adding? 1. Here, I am also adding 1 more element. Okay? And is there any way that I can add 1 more element?
Yes.
1 more element. What is that?
Add both ones.
No. 1 more element. 3 and 4, and 1 more element. Yes? Is there any other way that I can add? So what do you say if you say there is 1 more?
No, not just one.
Okay, not just 1 element. Now we go to 2 elements. Yes? So it becomes 3 and 4 and 2 elements. 2 elements are 1 and 2. Yes? I hope that you are not confused. So here, how many elements I added? I added 2 elements. So, no elements at all, 1 element and 2 elements. So, I don't want you, I don't know if you're confused or not if I do that, hopefully not. So here, let me write empty. Here, let me write 1. Here, let me write curly brackets 2. And here, let me write curly brackets 1 and 2. Okay, so forget about this momentarily. If I ask you, what do you see in this list? Can you say something? What do you see in this list? Empty set, this one, and that. These are all subsets of which set? What? The first set, 1 and 2. Yes? So, of course, I am not adding the empty set here, of course. But 0 is the number of elements here. 1 is the number of elements here and there. For this one, I have one option. For this one, I have a new option. For this one, I have a new option. Is that understandable? So what does it mean? It means the number of choices for x is in one-to-one correspondence with these choices. Is that right? So let me give you another example to understand what is going on. So for example, let me choose k to be 2 as before, but if you don't mind, this time let me choose n to be 5. Okay, so what happens? 1 and 2 is this one, union x. I want to have it 1, 2, 3, 4, and 5. Yes? I want you to understand the rule. Here, the minimum x is what? Because the union is supposed to be this. 1 and 2 are already in the union because they are here. Even if they are not here, they are still in the union, so that's okay. But x should contain this minimally these elements. Yes? So if I write this, then it means that how many choices I made from 1 and 2. So here. So what is another choice? So you see, this is one possibility. Another possibility is what? 3, 4, and 5 as it is, but I put 1 in it. And again, x is 3, 4, 5. This time I put 2 in it. It will work again. And then I would write 3, 4, and 5. What do I put in it? Both 1 and 2. Are there any other options for this case? No. You cannot guess any other number so that when I put it here, it gives me this one. Yes? Is that clear? One more example. Let me increase this one now. Okay? So, for example, let me write k to be 3, n to be 5. Okay? So what should I write? 1, 2, 3, union x should be equal to what? 1, 2, 3, 4, and 5. Do you agree? These are the cases. So what is the minimal x? 4 and 5. Yes? So the minimal x is 4 and 5. I cannot go below that, otherwise I violate this equality. But now, how many options do you think will be there? One option is just this one. One option is to do what? Add one more element. But how many one more elements I can add? Either I can write 4 and 5 and add 1 to it, or I can write what? 4 and 5 and add 2 to it, or I can write 4 and 5 and add 3 to it. Is that right? Okay? But this is not the only options. I can add 2 elements now. Yes, I can write 4 and 5, but add 2 elements to it. One option is to write what? 1 and 2. One option is to write 1 and 3. One option is to write 2 and 3. Do you agree? Yes? Do you see what I'm doing? Okay, and then the other one, is there anyone left? Yes, to add 1, 2, and 3. So it becomes 4 and 5, 1, 2, and 3. Yes? But now look, I'm not saying that I want to make a correspondence between these numbers. I want to count them. 1, 2, 3, 4, 5, 6, 7, 8. Okay? Of course, here in this case, I can write all of them and count them. The problem is finished. But if I want to find a pattern I need to do for k value and n value in general, I have to understand what is going on. This, how many of these elements I added here? Nothing. So let us say empty. I didn't add anything to it. Which ones I added here? Either only 1 or 2 or 3. Here I added 1, 2, 1, 3, and 2 and 3. And here I added 1, 2, and 3. Yes? I am not saying that so the word added or things like that. I union them, sometimes something like this. So I union this with the empty set. I got that. I union this with this one. I got that. I union this with this one. I got that. I union this with this one. I got this one, and etc. Yes? So it means that if you want to count how many sets you see here, instead of counting them, you can count how many sets you have here, because they are in one-to-one correspondence. But counting this is easy. If you observe that what have you listed here is all subsets of this set 1, 2, and 3. Yes? So you don't need to actually count them because there is a formula to it. What is the formula? Is 2 to the power of the elements of this set. So it is 2 to power 3. Okay, now this idea will work there. Yes? So now if I go back to the general case, okay, the minimal x is just take this one. Okay? Not union it with the empty set. The second one is, for example, 1 to up to k, add one to, add what to it? No, sorry, I should write what?
Yes, that's true.
Yes, this should be, not, this shouldn't be this one. No, sorry, the minimal is what? If I want to do same analogy, I have to write like this. X should be the rest of it. So what? K plus 1, K plus 2 up to N. Yes? If I union this with this, I will get that one. Okay? This is the standard one. The next one is consider the same idea, the same set, but, for example, add 1 to it. The next one, add only 2 to it. And the next one, I will add pairs of these numbers there. In any way, the total number of options that I have here is equal to the total number of subsets that I have here. And so the answer is what? Simply 2 to the power of k, because there are k elements here. So I designed this question so that you see that even the simple things might be a little bit confusing. But I hope that you understand what is going on. Of course, you might struggle a little bit because these kind of things we will study better when we come to combinatorics. But hopefully, what I try to do that for you, I try to make a one-to-one correspondence between the number that I want to count and the number of subsets of the first set. I try to convince you for any subset here, you have one single solution for your x. So instead of counting how many solutions for x are there, I can count how many subsets of this set I have. They are the same. Okay? So how many subsets are there? There are 2 to the power of k. So the answer to this question is 2 to the power of k, which is this option. Understandable? Okay, so any questions you don't have, I will stop here.